Take everything out of a box, every molecule, every atom, every photon of light. Pump it all out, seal it, and stand back. A perfect vacuum, the most complete nothing science can manufacture. Here is what is inside it. Energy, not a trace, not a residual. Enormous, restless, particle-generating energy. Quantum mechanics, the same theory that runs the processor in your phone, accurate to 1 part in 10 billion, tells us empty space is a seething ocean of virtual particles flickering in and out of existence too fast to catch. Real particles, real energy. The Casimir effect proves it. 2 bare metal plates, placed close enough together, get pushed apart by nothing at all. Now imagine that same energy, invisible, unnamed, untouchable, is pulling every galaxy in the sky away from every other galaxy, not moving through space, stretching space itself, the floor beneath your feet, the walls around you, the air between your hand and this screen, all of it expanding right now, driven by something that should not exist at the scale we observe it. If this force were even slightly stronger, the atoms in your blood would have ripped apart before the first star ever ignited. If it was slightly weaker, the universe would have collapsed back into a silent, dense point before anything had time to cool. You exist inside a margin so thin that calling it luck feels like calling a suspension bridge a coincidence. We call this force dark energy. We call it dark because we have absolutely no idea what it is, but it controls 68% of the universe, does not fit neatly on a textbook cover. Think of bread dough rising in an oven. You mix raisins into the dough. As it bakes, the raisins move apart, not because they are swimming through the bread, but because the dough between them is growing. The universe is the dough. The galaxies are the raisins. Please do not ask where the oven is. The analogy has suffered enough. In 1998, 2 competing teams of astronomers set out to measure how fast the universe was slowing down. Gravity pulls things together. Every star, every galaxy, every hidden mass should be tapping the brakes on cosmic expansion. The only open question was by how much. Saul Perlmutter led the supernova cosmology project at Lawrence Berkeley National Laboratory. Brian Schmidt and Adam Riess led the High-Z supernova search team. They were rivals. They barely spoke. Both teams used Type Ia supernovae as measuring sticks, stellar explosions with a known intrinsic brightness, standard candles burning at known wattage across the cosmos. Measure how dim the candle looks from Earth, calculate how far the light traveled, and you know the expansion rate at the moment the star died. Both teams came back with the same answer. The distant supernovae were dimmer than expected, farther than they should be. The universe was not breaking, it was accelerating. Someone had glued a brick to the gas pedal while nobody was watching. Both teams cross-checked independently, on different instruments from different continents. The result held. In 2011, they shared the Nobel Prize in Physics for discovering something that their own models said should not exist. And here is what makes the unknown worse. Dark energy does not thin out as the universe expands. Unlike matter, which spreads across more volume, diluting like ink in water, dark energy's density remains constant. As space grows, the dark energy in that space grows with it. It does not fatigue. It does not fade. It keeps pace with the universe it is accelerating. For something that does not appear in any equation that correctly predicts its value, that is a remarkable sense of commitment. Now we arrive at the number. Remove the academic anesthetic from it. When physicists calculate the expected energy of empty space using quantum field theory, and then compare it to the actual observed dark energy keeping you alive right now, the difference is a factor of 10 to the power of 120. That is a 1 followed by 120 zeros. The total number of atoms in the observable universe, every star, every planet, every grain of dust across 93 billion light-years, is roughly 10 to the power of 80. The gap between what physics predicts and what we observe is larger than the count of every atom in everything we can see. Not by a little, by 40 orders of magnitude on top of that. This is not a rounding error. This is the worst prediction in the history of science. And the universe's response was to not explode. Imagine walking up to a bank vault. The safe has a combination lock with 120 dials. Each dial has 10 numbers. You spin every dial completely blind, pull the heavy steel handle, and the door swings open on your very first try. You would not call that luck. You would call the police. You would say the game is rigged. If the dark energy in the vacuum were stronger by a single digit in that impossible sequence, the universe would have blown apart so fast that stars never formed. No stars, no carbon, no you. If it were weaker by a single digit, the universe would have collapsed back into a fiery crunch before the first microscopic cell ever had a chance to divide. Randomness, apparently, took the ultimate engineering exam and aced it. Without studying, a pencil balanced on its sharpened tip. Not for 1 second, not for 1 hour, for 13.8 billion years, while a Category 5 hurricane rages around it. At some point, shrugging stops sounding humble and starts sounding like a witness avoiding eye contact. The equations of particle physics must cancel each other to 120 decimal places for no reason the equations themselves provide. The math works perfectly, as long as you do not ask the math why. If human beings could understand and replicate dark energy, every power plant on Earth would look like a campfire arguing with the sun. Rockets would become instantly embarrassing. A rocket is a controlled explosion under a chair, aimed upward, supervised by paperwork. Impressive, yes. Elegant, not exactly. Now look at where we actually are. ITER, the International Thermonuclear Experimental Reactor in southern France, was built by 35 nations over decades at a cost of over 20 billion euros. Its goal, replicate the fusion reaction that powers the sun. Plasma at 150 million degrees Celsius, superconducting magnets operating near absolute zero, all in the same machine. Net energy gain is projected for the 2030s. When humans manage to hold a plasma stable for a few seconds, we celebrate like we have conquered physics. Dark energy has no reactor, no containment field, no 35 nations, and no budget. NASA has been working on deep space propulsion since 1967. They are highly optimistic about having something decent by the 2080s. Empty space runs it for free across every cubic meter of observable space, with no maintenance, no variance, and no invoice. We built billion-dollar instruments, DESI mapping tens of millions of galaxies from a mountaintop in Arizona, Euclid scanning the dark universe from orbit, the Rubin Observatory turning the southern sky into a 10-year time-lapse, all to ask nothing what it is doing. And nothing is still being evasive. Billion-dollar hardware staring at silence, hoping silence fills out the form correctly. The universe behaves like it was checked twice by someone who actually knew the math. There are no new equations coming to save us from this reality. No undiscovered particles waiting in the dark that will make the math less terrifying. Just the cold, hard weight of an impossible number. 1 part in 10 to the power of 120. The entire history of the cosmos, the birth of every star, the formation of galaxies, the cooling of Earth, the oceans, the continents, and the exact sequence of events that led to you sitting here, breathing, listening to these words, all of it exists entirely inside the microscopic margin of error of a phantom force we cannot see, cannot touch, and cannot explain. We are floating in a bubble of impossible precision, suspended over a dark, violent ocean that should have crushed us the moment we arrived. The numbers do not lie, they do not forgive. The precision is absolute, the balance is flawless. Who calibrated this, if no one calibrated it?